previous video we saw how the potential energy of a simple harmonic oscillator versus the position is a parabola, 1/2 of kx squared. Our particle under this motion with the specific energy E goes back and forth. When the particle is at the extremes of the trajectory, all the energy is potential. When the particle is at the center of the trajectory, all the energy is kinetic. The gap between the line of potential energy and the total conserved energy indicates the kinetic energy of the particle. Let's study this oscillatory motion from a potential energy point of view. One of the interesting aspects of the simple harmonic motion is that it is described by a parabolic potential energy. Even though not all motions in nature can be described by this potential, most systems behave under a potential that, for small enough oscillations, can be approximated by a parabolic potential well. For small oscillations about the potential well, the curve can be approximated by a parabola. Then we can use the results of the simple harmonic motion. This is part of the appealing and power of this kind of motion. Any potential can be written as a series expansion of Taylor about the specific point. If this point is at the center of the potential well, the value of the potential at the well can always be chosen to be the origin of energies. The first derivative is 0 because we are studying the center of the well and the slope right there is 0. Then we have the second order term, which is an x squared, just the simple harmonic motion term. If oscillations are small, we can neglect the higher order terms. Look that the steep of the slope means that for a tiny change in position, the potential energy changes a lot. This energy change is also a change in kinetic energy. So the particle gains or loses speed quickly. A change in speed is related with an acceleration, and therefore a force. The steeper the slope, the larger the force, which is something we already know. The force is related to the slope of the potential with. When the slope is positive, the force is negative, so pushing the particle to the left. When the slope is negative, the force is positive, so pushing the particle to the right. We can check this expression with explicit force and potential energy of a spring. F is equal to minus kx and U is equal to 1/2 of kx squared. If we derive the potential, we actually get the negative force. Science, be periodically with you.